When we're minimizing functions with a Karnaugh map, we have special types of terms for the encirclements: implicants, prime implicants, and essential prime implicants. When we're choosing adjacent squares, we want to ensure all min terms of the function are covered, for one, and then we want to make sure the number of terms in the expression is minimized. To do that, we want the number of variables per term to be minimized and to ensure there are no redundant terms. Sometimes, as we've seen, there's more than one expression that may satisfy the above criteria, but how do we make sure that we have met the above criteria? That's where we want to focus on using these special terms and understanding what it really means to be an implicant and a type of implicant. So implicants for sum of products, that's a rectangle of 1, 2, 4, 8, any power of 2, of min terms of the function that are ones of the function. So that rectangle may not include any zeros of the function, and of course the rectangles must be all adjacent to each other. So if we look at, for example, at this Karnaugh map, the implicants of the function in terms of min terms, we have here min term 0, but we'll express that implicant in terms of the variables. So that's our a prime, b prime, c prime, d prime. Here we have min term 3, a prime, b prime, c, d. That represents our min term 3. So this is how we'll name the implicants in terms of their expanded min term expression. So here we have 4, 5, 6, 7 min terms expressed in terms of their expanded variables. So those are implicants of the function in terms of the min terms. In terms of groups of 2, we have additionally, we have a prime cb. So our a prime, cd, that's these two up here. We have b cd, that's going to be these two here. And then we have ABC prime, ABC prime, that's these two here. Then we have ABD, ABD is these two over here. Additionally, though, we have ABC, ABC is these two in the middle. Well, actually, that's our ABD. Our ABC is these two over here, and our ABD prime is these two outside ones. So for these 4 min terms here, we have 4 different groups of 2 in which we can use to encircle them. In terms of groups of 4, we just have this one group of 4, which is our, that group of 4 is actually AB, isn't it? It says AB there. That's AB. Let's cross that out, show that correctly. There's our AB. So these are all different implicants. There aren't any groups of 8, and there aren't any groups of 16 in this map. A prime implicant is a rectangular product term that covers the maximum number of implicants from perspective of an individual min term and is not fully contained in any other implicant. So our prime implicant here, for this one, there's no adjacent terms. So that makes this min term itself a prime implicant. We also have these 4. So if we look at this min term here, it can be covered, the maximum number of cells it can be covered by are all 4 of these. So for this one here, that gives us the AB. Our A prime CD, if we pick, let's do this in red, if we pick this implicant here, the maximum number of cells it can be covered with is just these 2, right? So that's our A prime CD. Now we also, if we pick this one, well, that also has a prime implicant. It has the prime implicant A prime CD, but it also has this prime implicant BCD. We probably won't need BCD in order to cover all the squares. So our essential prime implicants are just we have to go through, we have to look at this cell, and this only has one essential prime implicant. That's right there. It only has one prime implicant, and that makes it essential. If we take this this cell here, it only has one prime implicant. The maximum number of cells it can be covered with are these two. So that gives us our well, that's this one here. That's our A prime CD. If we go to this cell here, the maximum number of squares to be covered with is all 4. So that gives us this essential prime implicant. So this term here, we don't need in order to cover all the cells, all the squares. So when we simplify this function, we'll just simplify it to f is equal to our A prime, B prime, C prime, D prime, or AB or A prime, C, D. So our BCD here, this essential, excuse me, this prime implicant BCD, it's a prime implicant, but it's not an essential prime implicant. It's an implicant because for this one here, this min term right here, it can be covered this way or this way, and both of them just have two cells associated with them. So it does make it a prime implicant, but it ends up not making it an essential prime implicant because since it can be covered two ways, it's a choice in there. All right, so that's, essential prime implicants are key. That's what we want to use to cover the cells. So if a min-term is covered by only one prime implicant, it is essential. And if we look here, any of these four, this one, the only way it can cover the maximum number of cells is the 4 corners. And that's true for each one of these in the 4 corners. If we pick any one of these 4 in here, the only maximum maximum of cells they can cover by are all 4. So these are our there are 2 prime implicants and there are 2 essential prime implicants. We'd end up solving this function f is equal to the sum of these 2 essential prime implicants, which are both the essential product terms. If we look at this one over here, if we pick this cell, that can only the maximum number of squares that we can cover by are these 4 at the bottom, and that's our A, B prime implicant. If we pick this cell, the maximum number of squares that can be encircled by are 4, and it's these 4, so that gives us our A, D prime implicant. If we pick this cell here, well, the maximum number of cells it can be covered by are these on the outside corner, and that's the only one that gives us the 4, so that becomes an essential prime implicant, and that's this one here. Now we have this one left to be covered. In order to cover this one, well, we can use CD, this column here, which is CD. So we get the 4 essential prime implicants. If we look, for example, so we'd end up solving this and saying that F is equal to the sum of these 4 essential prime implicants. If we picked, for example, as we're looking at this, if we picked at this one, and we tried to determine if there's an essential prime implicant associated with it, there are 2 prime implicants associated with it. We have the green associated with it, and we have this one here associated with it. So it has 2 prime implicants. So we don't want to choose this one as an essential prime implicant yet. And that's true for this square. It's true for this square. It's also true for this square. This has 2 options. It can be this one or the green one. And it's also true for this one and this one. It has 2 options. So we really needed to choose to determine the essential prime implicants, this cell, this cell, this cell, and this cell. And so that now we have the 4 essential prime implicants, and our minimized function will be the sum of all 4 of those. Let's look at one more example here. So in this example, we have the sum of min terms, and hopefully they're properly mapped onto this map. You can check that. And what we want to find out is what are the essential prime implicants of this map here. So, as I go to select, I'll select this one first and say, okay, it can be covered by the 4 corners. Since it can be covered by the 4 corners, that is going to give us a prime implicant here. but it can't be covered by anything else with 4 cells. So that becomes also an essential prime implicant. So this is our essential prime implicant, B prime, D prime. So now that we have that essential prime implicant, we'll go and look for another essential prime implicant. If we look, for example, at this cell here, it can be covered by this, and it can be covered by this. Both of those have 4. So this is not associated with an essential prime implicant. So we won't go to that one yet. Let's instead take a look at this one here. So if we look at this, this is our minterm 5. If we look at minterm 5, it can be covered by these 4 cells. And it can't be covered by anything else with 4 cells. If we go vertically, we can just do 3, and we can't do 6 cells. That's not a power of 2. So this becomes another essential prime implicant. So our other essential prime implicant here, that's BD. So we have this essential prime implicant. We have this essential prime implicant. Now let's see if we have any other essential prime implicants. If we look at if we pick this one, this can be encircled here or here. So it's not essential. We can't get an essential one from that, right? And similarly, if we go to that's same for this. This can be covered here or here. So we won't consider that essential. And that similarly, this can be covered by 2. This is the last minterm to look at. That can be covered by 2. So we don't have any other essential prime implicants in this map, but we haven't finished covering the cells. What we just uncovered was the non-essential prime implicants. So if we cover those again, these 2 then become non-essential prime implicants. Those non-essential prime implicants, the bottom one there is what is A, B prime, or we have A, D. Additionally, let's just erase those for a minute so we can see what's on here. So additionally, if we go to, and take a look at this one, then what we have is these 2. So we have this column is CD, or we have B prime C. B prime C. That's these 4 there. So let's erase these for a moment and see if we have any other non-essential prime implicants. Like we got all of them, so we could solve this function then in a few different ways. But every time we do it, we're going to need our B prime, D prime, or BD, and then we could use or AB prime, and then I'll do it like this. Then after we do AB prime, we could do our or CD, right? That's if we did. We could do AB prime, CD, and we finished. Or we could do, oops, let me use the eraser. Or we could do AB prime, or instead of using CD, we could use our B prime C. So, or we could do or A B prime, or I'm sorry, or what's this one? This one is B prime C, or which is this, right? Or B prime C. And again, we'd still need B prime, D prime, or BD. We have a couple other options as well, B prime, D prime, or BD. They both need these. And then instead of AB prime, we could use or AD. And we'll erase these for a moment. And our AD is where A is a 1 and D is a 1. That's that right there, right? So if we did the AD, now we still have, to cover this one, we still have the two other options. We could either use this, or we could use this here. So those are our two other options. So we have our or CD or B prime C. So we have 4 different possible equally minimized implementations of this sum of min terms, or this map, that will give us, each of them will give us the sum of 4 product terms. Each of the product term would have 2 variables. Each of the minimized functions would require us to be using the essential prime implicants, but we have some options in the non-essential prime implicants for our final implementation. Our reason for choosing the different implementations might be due to something else in the circuit. If we, for example, already have an AD in the circuit, then we'd want to use one of these 2 implementations. All right, that's it for this video.